Hello everyone, this is Saraj from AML and my topic of Tech Talk is a survey of information-centric networking. What problems in current internet architecture? The current internet was designed to address the communication needs of limited computers, including communication between in mainframe computers. The basic requirements from the internet at the time was merely that of forwarding packets of data among a limited number of stationary machines. The tremendous growth of the internet and the introduction of new applications to the fulfill emerging needs has given rise to new requirements from the current architecture. Many current and emerging requirements still cannot be addressed adequately by the current internet. This has raised the questions of whether we can continue the patching over patches or whether a new clean slate architectural approach for the internet is actually needed. Networking evolution. Traditional networking, host-centric communications addressing endpoints, information-centric networking, data-centric communications addressing information, example data in content, decoupling in space. Neither sender nor receiver need to know their partner. Decoupling in time. Answer not necessarily directly triggered by questions. Asynchronous communication. Here we can see the host-centric networking. If we observe connect server X and object B. Here the object B is there. This is the server. So we should connect it by the secure connection so that the data should be transferred. Here the server is there and the object is there. He is requested for the data. So this is the trusted server. So the data will be sent to the object and client by using the secure connection. Here we can see the transfer of the data by using the centric networking. This is the secure connection. This is the trusted server. This is the client. So the data is transferred from the server X to the client. Here we can see information-centric networking. If we clearly observe, these are the clients, this is the network, and we have the server. So if you want any data, so the client is requesting their parent that is there by using network, so that information is reached to the server. So the server will send the required information to the client by using the secure connections. So if we observe here, client 1 is requesting data H and H is requesting data D, the D is requesting data B, B is requesting data A requesting data server. So that server has to send the data by using the this is the centric networking information by using the centric networking. So let us see how it will send. So after the server receives the request, the server will check whether it is secure or not. So the server will send the data information to the client by using the secure connection. Here we can see from server to A to B, and B to D, D to H, and H to client. The client one is asked the information requested information, and the client one received the information from the server. For example, the client 2 also requested the same data to the server after the client 1. So we have already data at D. So we need not go to the again server. So we can easily get the data from the D. So that we can by using the secure connection. This is the centric networking. Already the D has the information that is sent to client 1. So the same data is requesting by the client 2. So the client 2 will get the data from the D to I to client 2. Here we can see D to I to client 2. What is the key functionalities of ICN? Information centric networking network. Naming, name resolution and data routing, caching, mobility, security. Let us discuss each and everything. Structure of a naming. First, naming. Structure of a name assigned to a piece of information to be communicated. In our ICN architecture, names are location dependent. Depending upon the approach, names may range from being flat to hierarchical. Names may or may not be human readable. Example of naming the data: flat, not human readable identifiers. Here we can see IDB76. There is no meaning of this naming. We cannot readable. We cannot even we cannot remember this whole thing. So it may not be the human readable identifiers. It should be flat. Hierarchical meaning structured names. That means here n times are sports, baseball, mates, games. These are the hierarchical naming. This is the flat naming. Name resolution and name routing. Name resolution involves matching an information name to a provider or resource that can supply that information. Data routing involves constructing a path from transferring the information from the provider to the requesting host. Name resolution and data routing can be coupled or integrated or decoupled or independent. In the coupled approach, the information request is routed to an information provider, which subsequently sends the information to the requesting host by following the reserved path over which the request was forwarded. In the decoupled approach, the name resolution function does not determine or restrict the path that the data will use from the provider to the subscriber. For example, an independent data routing module may send to the provider a resource route to the requesting host. Caching. A caching is further divided into on-path and off-path caching. In on-path caching, the information is cached along the path taken by a name resolution request. In off-path caching, the network exploits information cached outside that path. In ICN architecture with decoupled name resolution and data routing off-path caching must be supported by the name resolution system, which handles caches as regular information publishers. If name resolution and data transfer are coupled, off-path caching may be supported by the routing system used to forward the request for information. This is the caching. Mobility. What is mobility? Subscribers mobility is intrinsically supported in ICN architectures. Mobile subscribers can just send new subscription for information after a handout. Publisher mobility is more difficult to support since the name resolution systems in the coupled approach or the routing tables in the decoupled approach need to be updated. Security. This accept is tightly related to the naming structure. Here we can see human readable names and flat names require a trusted agent or a trust relation with the name resolution system to verify that the written information corresponding to the requested name. Flat name can support self-certification, not human readable, thus requiring another trusted system to map human readable names to flat names. Here the differences of the naming security. Security defines the readable names. If it is human readable and the flat name, if they are not human readable, it is very difficult to understand what it is. So This will provide the security. DONA, Data Oriented Network Architecture, created by UC Berkeley, changes naming by replacing the hierarchical URLs with flat names. Names in DONA allows user to verify that the received information matches a requested name via cryptographic techniques. Naming. DONA names are organized around principles. Each principle is associated with the public-private key pairs. Names are of the P colon L. P is the cryptographic hash of the principal public key and L is label chosen by the principal who ensure that these names are unique. Naming granularity is left to the principals who are considered to be the owners of the corresponding information. For instances, principals may name either an entire website or each individual web page within it. Names are flat, application independent, location independent, and global unique. Name resolution and data routing. Name resolution is DONA is provided by the specialized servers called resolution handlers. There is a least one logical RH at each edge. RHs are interconnected forming a hierarchical name resolution services. DONA architecture. This is the DONA architecture. This is the router. This is the RH and another router. There here we have the four routers. This is the we can see here the dotted lines indicates the pairing links and the straight line indicates the client provider link and this orange color line indicates the register message. This yellow color line indicates the message find message. Blue color line indicates the data. From publisher to router we are sending the data and router here one to another router we are sending data and subscriber will receive the data. From the subscriber we are finding messages. Find this indicates the finding messages. From subscriber we are finding the message from the publishers register message. Register message means here we can see publisher will send message to RH and here AS1 to this orange indicates the register message. This is the DONA architecture. Caching. DONA supports on-path caching via the RH infrastructure. A RH that decides to catch a requested data objects and can replace the source IP address of an incoming find request with its own IP address before forwarding the message to the next RH. As a result, any responses will surely transfer the current RH, thus the data returned will be cached there. If a subsequent find message requesting the same object reaches a caching RH, the RH can directly return the data to the subscribers. Mobility. Mobile subscribers can simply issue new find message from the current location, relying on the RH infrastructure to provide them with the closest copy of the information. Mobile publisher can also unregister and register their information when changing the network location. Security. Name is a donor or selfing certified. They allow the subscriber to verifying that the data received matches the name requested. The design of donor can either prevent or mitigate a series of attacks to the RH infrastructure. A RH will also accept information registrations by authenticator principals. Thank you.